BIGTREETECH just put out their new Filament Runout Sensor 2.0. In this video, we're going to go through the differences between version 1, do the installation, and the Klipper configuration. So stick around because you just might learn something. This is everything that comes in the box. You get your filament runout sensor, user manual, couple PTFE tubes, your couplers, some mounting screws, your wire harness, and this is going to be a different wire harness than that comes with the version 1. You get a couple extra, I guess these are retaining clips for the couplers. You get these 2 rubber pieces. I'm not sure where they go. There's nothing in the manual that says. If you know where these go, just drop it down in the comments. I think they're just extra, or maybe for a bone-in setup or something. You get, and then you get 2, these are locking clips for the couplers. Just to show you how this coupler works. So you go ahead and you could fit the tube inside, and it locks in with a spring in there, or like a clip that compresses and holds it in. To release it, you press this, so the black portion here, you can press it down and you can see how it's moving up and down. So when you press it all the way down, you could take this out, take the tube out. So, and that's what these clips here are for. So you could fit that clip underneath there, and that way it locks it in, and that tube won't come out. So for comparison, here's the version 1 of the filament runout sensor and the version 2. So you could see quite a big difference in size, and just a kind of updated style with the newer one. So we'll go ahead and open these up and look and see what's different inside. We'll look at the version 1 first. There are 6 screws on the back, and you can remove the cover. And from here, this piece, this is the actual electronic portion here. So underneath there are 2 1.5 millimeter screws here that hold the encoder in. So you can go ahead and loosen these up and remove this encoder. Here's the encoder for the version 1. You can see I have a version 1.2. With that removed, you can go ahead and remove this portion. It's just held in there with pressure from this spring. So this is the spring here. When it's inside there and you insert some filament, it puts tension, puts pressure on the actual filament. And then in here you could see that the encoder would go over this encoder wheel. And there are some, it's difficult to see, but there are some holes around the perimeter of the wheel that does the encoding. So with this filament runout sensor, it just has the encoder on it. So it's just looking for filament going straight through it. It's not looking to detect if there's filament inside. It's just seeing that there's filament passing through the sensor. Let's go ahead and open the version 2.0 filament runout sensor. I already took the screws out. There are 3 1.5 millimeter screws. So you have 2 shorter screws on this side, and then 1 longer screw with a washer on this side here. That's these screws right here. With that, you can pop this side cover off, and then here you get access to the encoder board, PCB board. That's comparing to the first version here. So it's a different board in there. This says version 2.0, and that's just held in with these 2-prong connectors that sinks into, there's these two holes right there. And then it has a totally different encoder wheel. It's a plastic wheel instead of that metal one in the first version here. So this had a metal wheel with a rubber kind of tire on it and metal rollers, and that was the encoder there. This one has a gear, or like a tooth gear in there, and the encoder up at the top here. The encoder components look identical though. And then you're able to pop this back cover off also. And now you have access to everything. So you can see that encoder wheel here. And we could take it out here. So you have a couple bearings in there. And then it's similar to like your extruder with that tooth gear. Looks like you can pull this straight off. And it's got a slot cut in there where it seats on. So you could put the encoder on the correct way. And then in here, unlike the version 1 that just detects if there's filament flowing through with the encoder, this one actually has a little switch in there, if you can hear it, that detects if there's filament inside. So not only does it detect now that there's filament, getting pulled through it, but it's also detecting if there's filament inside. So that's one of the main differences between the first one. The first one didn't do that, and this one added that. And those two wires where those two prongs go to connect that switch to the main PCB. So let's go ahead and jump over to installing this and configuring Klipper. Real quick, I just wanted to show you how the encoder works. So you could see on the PCB there are two pieces to it. Those fit between, or the encoder wheel fits between those, and when it's spinning, the encoder can see these notches in the wheel. So it knows that this is rotating because of those notches in the encoding wheel. So if it stopped, it wouldn't see any change, and it would know that either it's jammed or there's no filament in there. And I guess it can compare against this switch here to see if there's either no filament or if it's actually jammed. In order to attach it to my 3D printer, I had to create a bracket. So I used Fusion 360 and took some of the measurements off of both the manual and just taking measurements off the sensor itself and created a bracket here. I'll throw this up on Thingiverse, and if you need it, you can go ahead and download it from there. So let's go print this out and attach the sensor to the frame. I printed off that bracket and attached it to the sensor, and then attached the sensor to the frame. So you could see there how it's attached just with a couple bolts. Now that filament is some new filament from Yusu. I can leave a link down below for that filament. It's some new stuff that they put out. You can see it here. It's pretty cool stuff. This is the color changing glitter filament that they just came out with. So it goes from purple to blue to green. It's really cool stuff. Easy to print PLA. Now for the sensor, since the sensor is bi-directional, so it doesn't matter which way you mount it, I actually mounted it upside down so I can have the cable come out this direction to be routed back to my printer, or the printer board. So you could see my cable runs along under the frame, and I printed some of these clips here. See if I can get it in focus. So some of these clips to clip in the wire inside of the frame itself. I can leave a link down below where I found these and printed them. They're really useful. So I went ahead and routed that back to the board and connected. For wiring the filament runout sensor, we'll refer to the user manual. So here you can see there's two connections that need to be made to the main board. Here's the cable that comes with the kit. So there's a 4-pin connector that goes to the sensor, and then two 3-pin connectors that go to the board. Since this one has an additional feature for detecting that there's filament inside, that's why we're going to need to use these two connectors. If we look at the version 1 harness, it's just a 4-pin connector here that goes to a 3-pin connector. So like we showed earlier in the video, the version 1 is only going to detect if there's filament running through and not actually detect there's filament inside of it. In my case, my board is far away from the sensor, so I had to make my own harness. So what I did is I took the original harness that came with the sensor and took off the two 3-pin connectors here and put a 4-pin connector on it. Then I made up my own wire harness here that goes from a 4-pin to the 2-pin here. So I made like a little extension cable for it. You just need to make sure, following the color codes here and where the pins go, just to make sure you're putting the wires in the correct location. If you don't and you cross them, you have a risk of damaging the sensor itself. Now let's jump over and I'll show how I installed it on my machine. Here's the connection diagram for the sensor. So you can see that it's using E0 and E1, and it's using a pin for the motion sensor and a pin for the switch sensor. Now I have Klipper installed, so I'll be using this code here. So my switch sensor is going to be put here. For the pin that I'm going to be using, I'm going to input it here. And then for the motion sensor, I'm going to enter that pin here. So to do that, we need to look up our board. So I have an SKR version 1.4, the turbo version. So here's my E0 right here and my E1 connector here. So if we look over to the pins, we could see that E0 uses 1.26 and E1 uses 1.25. Back on this diagram, so E0 was 1.26, so my motion sensor is going to be 1.26 and my switch sensor is going to be 1.25. Jumping over to my Klipper install, this is my printer.config file, and if you haven't ever ran a runout sensor before, you won't have this code, but this is my code from the version 1, so I had to go and comment that all out, and you just comment it out by either you can delete it or just put a pound in front of each line and that'll comment it out. And then what I did is I copied that code that was shown in the manual and pasted it in here. And then you could see that I inputted a P1.25 for the switch sensor and a P1.26 for the motion sensor, but I had to put a exclamation in front of that. That's needed because the sensor was reporting the opposite state that it was in. So it was actually false and it was reporting true, or if it was true, it was reporting false. So in order to invert that, you have to put an exclamation. We'll go ahead and save this file and start up the printer, and we should be good to go. We'll just go ahead and test it out. So I have everything installed, and this is the sensor. I put some filament in there to test, and you could see this is in the instruction manual here, that that light, it will be red when there's no filament in the module. Blue light will flash when the extrusion is normal, and blue light will stay on or off when there's no extrusion. so when there's just filament in there. So you could see the LED is on, that it says there's filament in there. If I move the filament, you could see the light flashing, and if I take the filament out, it turns to red. So it's working as it should. Going back to my Klipper install, you could see down here that it's detected, the encoder is detecting it, and the switch sensor is detecting it. So if I take it out, now you see the switch sensor goes to empty, and when I put the filament back in, it's there again. So the encoder sensor, that would detect your jamming, so I'd have to print it and then hold the filament probably so that it simulates a jam. The status would change on that and it would stop the print. So everything seems to be working correctly. I did notice one thing is sometimes both red and blue lights turn on, so it becomes almost purple, and there's nothing in the manual that says anything about that. So there's red. If I barely touch the filament inside, it turns to like a purple color. So I don't know if that's like an air color code or something. So yeah, everything's working as it should. Installation was pretty straightforward. Everything worked, right away. I didn't have to tweak just that piece of code, the code in here, to my configuration file, and everything went smooth. Just make sure you have the connectors in the right location, because they are 3 pins, so they can go and they can be switched around. So just make sure you have them in the correct location. Even if you switched it around, it wouldn't burn up the sensor, because over here there's no ground pin. So if you switched it around, you shouldn't fry this, but just be careful. And if you scroll down, so I had to clip the Klipper installation, so I used this code, but they also had for Marlin, if you have Marlin. I would highly recommend this. Installation was pretty quick, and at the time I bought it when they first launched it, and I think I got it for $10 or something like that. And now I think they're at 18 bucks possibly. I'll leave a link down below for it, but it's just a cheap add-on that could save your print. If you're printing a long print and you run out of filament, it's a bad day for you. So this is kind of like a safety feature for you to help save your print. Anyway, yeah, if you enjoyed the video, please give it a thumbs up. Appreciate you guys taking the time to watch this one, and we'll see you in the next video.